Hi everyone, let's do a quick recap of what we talked about in class. I'll give you a quick overview of what the various classes are, and then we'll talk about the game loop, we'll talk about sprite sheets, we'll talk about world coordinates and screen coordinates. Okay, so the way the game is organized is inside these various packages. I have retained Van Zieben's original package names to give him credit for making the original template. Notice the names. So game contains all of the game level related things. Entities is going to contain classes related to the entities within the game. Right now we only have a player. GFX contains all of the classes that are relevant to graphics, such as Sprite Sheet, which represents a sprite sheet. Screen, which is the main class that you use to render things. And Font, which represents fonts. Then inside Level, you have all the classes pertinent to levels, which is just one level, and then tiles. There's a number of classes related to tiles. If you're unfamiliar with the word tile, tile in this context is being used just to refer to like an individual background tile. Okay, so let's peek into some of these. So Game Launcher, its only job is to create a game instance and to launch it in the right way. The main interesting game loop happens here in game inside the run method. You can read about what all this is doing, but the two main important methods that are getting run in an infinite loop here inside game are tick and then later on render. So tick is another word for update. So what this does is this tells the entire game to update itself by one time step. And this renders that time step to the screen. So if you want to sort of trace step by step what happens when the game runs, this would be a great place to start. As a navigational strategy inside Eclipse, if you hold Control and you click on a method, it will take you to that method's declaration. So here, this has now taken me to the tick method inside game. So it looks like what happens when the game ticks is we just tell the level to tick. So let's look at what happens there. When the level ticks, it looks like the level asks the player to update itself, and then it loops over all the tiles and tells every tile to update itself. So that's about having the background update itself. Okay, well let's see what happens when the player updates itself. Here I am inside player. It looks like we're checking to see what keys are being pressed down, and then later on we're telling the player to move in a certain amount by X and Y. And then we've incremented our tick count. So that's just an example of how you yourself can explore a little bit about how things happen inside this framework. All right, let's look at some of the notes that I've made for you. So sprite sheets. If you don't know what a sprite sheet is, this is an example of a sprite sheet. It's a single image that contains a grid of smaller images. The idea is this is a more efficient way of representing the graphics in your game than having a separate file for every image that you'd want to display. So we have a class called Sprite Sheet that is basically just a container for this image that's a sprite sheet. When you instantiate the Sprite Sheet class, well, let's look at it. When you instantiate the Sprite Sheet class, which is inside graphics, you give it a name, such as, for example, dungeon. You give it a path, which is the file path for the particular image that you want to load. Then you tell it how many sprites high and how many sprites wide it is. So in this example, it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8 wide, and 1, 2, 3, 4, 5, 6, 7, 8 tall. So when I'm creating it, I would say, as I do here, 8 by 8. Okay, then inside the constructor, we actually load an image, and where do we do this? So we actually load an image here, and then we ask the image what is its width and height in actual pixels. So that's how the sprite sheet calculates the pixel width and height of an individual wizard image in here. Is it takes the entire pixel width of the image, and it divides it by how many particular tiles you told it were in there. So in our case, if this were, for example, 128 pixels wide, and we were dividing it by 8, then I think that would be 16. Is that true? Yeah, 16. So 128 pixels wide for the whole image. I tell it there are 8 They're 8 tiles wide, and so now it has calculated that the width of each wizard tile is 16 pixels. So the Sprite Sheet class does that for you. Okay, whenever you ask the Screen class to render something for you, here inside Graphics, the Screen class has a whole bunch of methods that are just about rendering particular images on the screen, and they all look like this. So your player, for example, will have a screen object available, and it will tell that screen object to render a particular image from a sprite sheet at a particular location on the screen. So here we give it an X position and a Y position, and these are in world coordinates, which I'll tell you about in a minute. You give it you give it the sprite sheet object that contains the particular image you want to display, and then you tell it the tile row and the tile column, and that's referring to which one of these images, like how many down and how many over, is the particular one you want to display. So as an example of this method right here comes from the player class. Let's look at just this first screen.render. So screen is a particular instance of screen. I'm running a render method, and I give it the XY coordinates, which are the world XY coordinates where I want to display a wizard image. I give it the sheet. Sheet is a sprite sheet instance. And then I give it 0, 0, which is row 0, column 0 inside this tile sheet. So that's this wizard that's just standing right there. Okay, notice this 0, 0 doesn't actually refer to pixel coordinates. I'm not talking about pixel 0, 0 up here. I'm talking about how many tiles down you are and how many tiles over you are. And the render function handles figuring out what pixel locations in the image that actually refers to. So all you do as a user of the render method is you just tell it which tile you want to render. There's also the possibility of telling it to render the image mirrored in one direction or another, but right now we're giving it no mirroring at all. Okay, so what happens is it will take that particular image out of your sprite sheet, and it will render it somewhere inside the screen at a particular set of world coordinates. So that's just a quick example of how render works. You should definitely poke around the screen class and look at what are all the different render methods that are available, because there's a whole bunch of them. Here's a picture that hopefully clarifies what I mean by world coordinates and screen coordinates. So the actual level is very large, and the world coordinates refer to a pixel location in the entire level, where the upper left-hand corner of the level is 0, 0. Screen coordinates refer to a pixel location relative to the upper left-hand corner of the screen that's getting displayed right then. But the screen itself has a location within the world. So, for example, let's say that this black rectangle represents what's being displayed on the screen right now. The black rectangle, the upper left-hand corner of it, might be located at world coordinates 64 by 16. The wizard might be located at screen coordinates 80 by 32, which means it's 80 pixels from the left, 32 pixels from the top. Okay, well, where is the wizard inside the world? Well, all you have to do is take the wizard's screen coordinates and add on to it the location of the screen in the world. So, for example, it's 64 pixels to get from the edge of the world to the screen, another 80 pixels to get from the edge of the screen to your wizard. So add those two together and you get 144, which is the world X coordinate for your wizard. You can also imagine easily how, if you had a world coordinate, you could calculate what your wizard's screen coordinate would be based on that. So it's fairly normal to have several different coordinate systems and to have methods that will translate back and forth between the different coordinate systems. So if I have world coordinates and I want screen coordinates, how do I do that, or vice versa? The only important thing is to have this picture in your head, have a mental model of how this works, because the screen class has some render methods where you tell it what screen coordinates you should render something at, and other render methods you tell it what world coordinates you should render at. As a note, if you try and render at world coordinates that are not currently being displayed, nothing will happen, because it would be pointless to try and render things that are not currently where the screen is.